Any problem, better? Homework question?
No, ma'am.
No
Ma'am,
problem. Better.
ma'am, please discuss the doubt which I was having in skew symmetric matrix.
Yes, better you asked me, see either A equal to minus A transpose or A minus A equal to A transpose, one and the same thing, better. What happened to you? You take this minus to that side. What happened to you? Either A equal to minus A transpose. Actually what we do, A matrix given, then we take A transpose. Then if you take minus, then we get back A matrix. So A transpose equal to minus A. This implies A equal to minus A transpose. We say this matrix is skew symmetric matrix, then A equal to minus A transpose. Otherwise minus A equal to A transpose, one and the same thing. Are you clear?
Okay, ma'am.
Okay. Any
Yes,
other
ma'am.
doubt? Yes, beta. Any doubt? Shall I start next one? Okay, beta, today we are board is visible for everybody. Okay, now beta, see properties of determinant. There are total 6 properties. Using these properties, we will solve some questions. Definitely one 4 mark question is there. ये टॉपिक सेपरेट कर देना, इसमें से एक 4 मार्क क्वेश्चन जरूर आएगा. So you should know how to prove this properties. अभी proper statement दे रही हूँ, proof करा रही हूँ, ढंग से सुन लेना. Now property number 1, you start right. Property number 1, the value of determinant remains same. The value of determinant remains same. Determinant remains same if rows and columns are interchanged. If rows and columns are interchanged. That means what they are saying, if you are interchanging rows into columns, the value of determinant remains unchanged. That's they are saying. Now that is, I am going to prove that is what they are saying. Determinant is always denoted by delta. Delta is capital delta, this one. That is equal to delta transpose. Okay, now I am going to prove this. Solution I am taking. Now I am taking delta equal to, that is A1, B1, C1, and then A2, B2, C2, A3, B3, C3. Okay. Now what I am going to do here, R1 and row R1 goes to C1 and C1. That is row and column I am interchanging. Row goes to columns and the column comes to rows. I am taking complete transpose. Now delta transpose equal to, if I interchange, you open this, first you open this, then we can do it. Okay, first open this. Open the bracket, associate this determinant A1 into multiplication. Now I am doing directly, delete corresponding row column multiplication of downward B1 C3 minus B3, sorry, B2 C3 minus B3 C2 and minus B1 into delete corresponding row column. You also check it, A2 C3 and then minus A3 C2 and then plus C1 into delete corresponding row column. What we will get it better? A2 B3 minus A3 B2. Okay, fine. Now this is equation number 1. Now I am taking R goes to row goes to column and the column comes to where? Row. So that is delta transpose equal to, what we will get? A1, A2, A3 and then B1, B2, B3 and then C1, C2, C3. But already I told you one concept. I can open this determinant with the help of row or column. The answer is the same. So what here I expand using R1. The same element A1, B1, C1. Where is it here? A1, B1, C1 and column C. With the help of C1 you have to open the determinant, very immediately you will get answer. Either if I use R1 or C1, value is the same. That's already we have proved in first exercise. Now I'm going to expand using, so there is no different, okay, expand using C1, If I use this, delta transpose equal to, now A1 into, this is a plus minus, this is a plus, this is minus, this is plus. Now A1 into delete corresponding row column, we will get it to B2 C3 minus C2 B3. and then next minus B1 into delete corresponding row column A2C3 minus C2B3, sorry, which one? This one, and A2C3 minus C2 A3, and then plus C1 into delete corresponding row column, we will get it A2 B3 and then minus B2 A3. Now see result number 2. This is result number 1, result number 2. From 1 and 2, check it better. From 1 and 2, delta equal to what we are getting? Delta transpose. So what property is saying? The value of determinant remains the same if rows and columns are interchanged. So that's we have taken, that is delta equal to delta transpose. So delta I have taken here with it. So I have opened this equation number 1. Now delta transpose, ये रहा आपके सामने. Now we can open this determinant using R1 or C1, one and the same thing. I'm taking with the help of C1. Why I'm taking with the help of C1? That same element here in R1, that's why I'm taking C1 here. Immediately we will get a result. Now I open this determinant using C1 and getting both results are same. That means delta equal to we are getting delta transpose. Are you clear with that? Are you clear?
Yes, ma'am.
Yes. Write down fast better. Then I will take another property. Fast. Noted better?
Yes, ma'am.
Yes, better. Now property number 2 I am taking. Next write. If any two rows are columns, better start right everybody. If any two rows or columns are interchanged, if any two rows or columns are interchanged, property number 2, if any two rows or columns of a determinant are interchanged, then the value of determinant gets sign changed. The value of determinant gets sign changed. Okay, fine. If any two rows or columns of a determinant are interchanged, previously what we have seen, if we are interchanging rows into columns, the value of determinant remains same. Now what they are saying, if we are interchanging any two rows or any two columns, then the value of determinant gets sign changed. I'm proving better now here. Now delta equal to same, I'm taking A1, B1, C1 and then A2, B2, C2 and then A3, B3, C3. Now that is equal to, if I open this, that is equal to A1 into Y, same using, expand using R1, A1 into delete corresponding row column, B2, C3 and then minus B3, C2 and then minus B1 into delete row column, we will get A2, C3 and then minus A3, C2 and then plus C1 into delete row column, we will get A2, B3 and then minus A3, B2. That is equation number 1. Now I'm interchanging, that is at your choice, any two rows or two columns. I'm not saying row and column, okay. If you are interchanging R1 and R2, R1 and R3, the same vice versa, C1 and C3, C1 and C2, that is up to your choice. So I'm changing here, R1 goes to R2 and R1 comes to where R2 comes to where R1. I'm interchanging first row and second row. Okay, now delta 1 I'm giving name delta 1. So delta 1 equal to, if I interchange, this is A2, B2, C2 and then this is A1, B1, C1 and then this is A3, B3, C3. Now I'm going to expand using expand using R2. Either if I use R1, R2, R3, one and the same thing. For my comfortability, I'm using here, I'm taking this R2, I'm going to open the determinant. Now anyhow, sign consider, this is a plus and this is minus and this is minus, this is plus, this is minus. Now anyhow, if I open this minus A1 into delete corresponding row column, we will get it B2C3 minus B3C2 and then plus B1 into delete corresponding row column A2C3 minus A3C2 and then minus C1 into delete row column, we will get A2B3 minus B2A3. Now anyhow, if I take minus outside from this element, so A1 into I will get B2C3 minus B3C2 and then minus B1 into I will get A2C3 and then minus A3C2 and then plus C1 into A2B3 minus B2A3. That is equation number 2. Now see, I'm getting that's equal to delta 1 equal to, I'm getting minus delta. Delta 1 equal to minus delta. Delta era minus delta era value, but we are getting minus here. So what a property is saying, if we are interchanging any two rows or any two columns, then the value of determinant gets sign changed. Clear? Clear? Beta samajh aaye?
Yes, ma'am.
Okay, write down fast. Write down. If you have any doubt, immediately ask me. Maybe proof 2 mark question, maybe it will come, or otherwise 1 mark question. This time how they asked 1 mark question, from 4 mark question they created 1 mark question. That's I will tell you. First write down all properties. Have you written better? Write fast. Done? Say yes, no beta immediately. Yes. Yes, beta.
Yes, ma'am.
Thoda write fast, bachche, write fast. Otherwise, we cannot even complete properties, you know. Now, I'm taking another property. Have you written, everybody? Now, write property first, property number 3. If any row or any column, if any row or column is multiple of k, is multiple of k, then the value of determinant, value of determinants gets multiplied by k, multiplied by k. Once again, if any row or any column is multiple of k, any row, but what we have seen in matrix, if you want to take out 2 from a matrix, you have to take out from each element 2. But here what they are saying, mind it, if any row, any single row, single column is multiple of k, then the value of determinant gets multiplied by k. Means you can take a common element from any row, means R1 you can take, R2 you can take, R3 you can take, separately you can take. That's they are saying here. Now let me proof I'm giving, let delta equal to, same I'm taking A1, B1, C1 and A2, B2, C2 and then A2, B2, C2 and A3, B3, C3. If I open this, that's equal to, expand using R1, A1 into B2, C3 minus B3, C2 and then minus B1 into A2, C3 minus A3, C2 and then plus C1 into, we are getting A2, B3 minus A3, B2. Okay, fine. That is equation number 1. Now what they are saying, if any row or any column is multiple of k, then the value of determinant gets multiplied by k. Suppose delta 1 equal to, if I take k1, k, I am not multiplying. If any row or any column is multiple of k, already given beta, this is k c1 and then a2, b2, c2 and then a3, b3, c3. If I cannot take out directly. Let me prove this. Now delta 1 equal to, if I open this with the help of R1 KA1 into B2C3 minus B3C2 minus KB1 into A2C3 minus A3C2 and then plus KC1 into A2B3 A2B3 minus A3B2. Anyhow, now we have associated, we can take out a common element K here. So A1 into B2C3 minus B3C2 and then minus B1 into A2C3 and then minus A3C2 and then plus C1 into, that is A2B3 minus A3B2. Now this is equation number 2. That is what we are getting, that is equal to K into delta. So delta 1 equal to, we are getting K into delta. So what they are saying here, now listen better. If any row or any column is a multiple of K, then the value of determinant gets multiplied by K. So suppose now listen here, suppose another K, otherwise K is here. Then one K I have taken out, another K you have to take out from here, K square. If anyhow multiple of K from here, that means each element, that's minded. Suppose here is multiple of K, here is multiple of K. If there is no multiple of K, then you cannot take, that means divided by K, you automatically will get it. So that means if each element of a row or column is a multiple of K, then the value of determinant gets multiplied by K. So mind it once again, each row or each column. Okay, fine. Are you clear this one? Say yes, no.
मैम
Yes. हाँ बोलो बेटा.
मैम इसमें अगर हम कोई प्रॉपर्टी यूज करते हैं तो उसकी स्टेटमेंट लिखनी होती है ब्रैकेट में साइड में.
नहीं बेटा, no need at all, no need at all. That's I will let you know when we are doing the question. That time I will explain how to write the property. That means through notation we will write. I will not write the statement. If it is one more question, if they are asking any statement, then we will write. Otherwise, how to use the property, that's let you know when we are solving the questions. Okay, we cannot write every time statement better. Have you written better? Everybody writing. Yes. Everybody have written.
Yes, ma'am.
Yes, better maintain your classwork properly. That's again I'm saying, I don't know lockdown period when it will go, up to which month, that's even we don't know anything about it. So be alert, take it seriously. आप ये सोचोगे क्लास चल रहा है हमारा रेगुलर, that's ignore mind. Now I'm taking property number 4. Total there are 6 properties written. So now fourth property, write if any two rows or columns are identical. If any two rows or columns are identical, then the value of determinant is 0. Property number 4, if any two rows or columns are identical, then the value of determinant is 0. Value of determinant is 0. Now let me prove better. Delta equal to, I'm taking delta. If any two rows or columns are identical matlab same. See A1, B1, C1. I'm taking again A1, B1, C1. And this is A3, B3, C3. Okay, fine. Now open this determinant. With the help of R3, you have to open easily, you will get answer. Otherwise, you have to simplify, then you will get it 0. Now, anyhow, plus, minus, plus. This is plus, this is minus, this is plus. Expand using R3. Expand using, you no need to write. I am writing this sentence because of you. Expand using R3. If I open this, then delta equal to A3 into delete corresponding row column B1 C1 minus B1 C1, B1 C1 minus B1 minus B3 into delete corresponding row column A1 C1 minus A1 C1 and then plus C3 into, if I delete corresponding row column, that is A1 B1 minus again A1 B1. So totally we are getting 0. Here R1 and R2 are identical. Here R1 and R2 are identical. So that's a property saying if any two rows or columns are identical, then the value of determinant is 0. Note down beta, note down fast. Noted beta? Noted?
Yes, ma'am.
Yes. Now property number 5. Beta noted everybody. Some students never speak. Some students never speak. I don't know why. Now anyhow property number 5 I am taking. What property number 5 is saying? Better start right statement first. If any two rows or columns, if any two rows or columns are proportional. What is meaning of proportional? That I will tell you. If any two rows or columns, if any two rows or columns are proportional, then the value of determinant is 0. If any two rows or columns are proportional, then the value of proportional matlab unique multiple होगा दोनों का. Now let me explain. Now I am taking delta equal to, so that is a1 b1 c1 and k into a1 k into b1 k into c1, that is a3 b3 c3. Here R1 and R2 are proportional. Proportional means same multiple. Ratio is the same. Ratio should be same. Here R1 and R2 are proportional. Okay, now open the data. Just now we have seen one property. If in any row or any column is a multiple of k, then the value of determinant gets multiplied by k. Am I correct? Am I correct? Did you see this property? Now, for using that property, if I take out k from take out k from where R3, R2. Now that is equal to k into what we will get to a1 b1 c1. Then again a1 b1 c1, a3 b3 c3. Just now we have seen the property if any two rows or columns are identical, then the value of determinant is 0. Now that is equal to k into 0. Here I am writing like this, we have to use the property. Since R1 and R2 are identical. Okay, fine, identical. Now that is equal to k into 0, we will get it 0. So what property is saying, if any two rows or columns are proportional means ratio should be same. Proportional, then the value of determinant is 0. That's I have proved better. Write down fast. Have you written? Say yes, no. Fast, hurry up. Have you written? Another last two property evaluated total 7. This is note actually, that's I have given number 5. Last two properties are most important and frequently we will use the property. Okay, so try to understand what is the property first. Have you written everybody? Yes?
Yes, ma'am.
Okay, beta. Now property number 6. Write statement first along with me when I am dictating. Now, property number 6. If some are, that is property number 7. If any row or any row or column is a sum of two or more elements, then the determinant, then if any row or any column is a sum of two or more elements, then the determinant can be can be expressed sum of two or more determinants. But one of the most important property, if here you can write even if some are if some row or column, that means SOME sum. Otherwise you can write like anything like this. If any row or any column is a sum of two or more elements, then the determinant can be expressed as sum of two or more determinants. Like that is I'm giving property here, that is A1 plus alpha, and then B1 plus beta plus C1 plus gamma, then A2, B2, C2, and then A3, B3, C3. That is equal to A1, B1, C1, and then A2, B2, C2, and then A3, B3, C3, plus what they are saying, that is alpha, beta, gamma, or otherwise A2, B2, C2, and then A3, B3, C3. So that's why I told you any row or any column, or otherwise if sum of row or column, sum means SOM. Suppose if any, this is, see, first row I have split it into two determinants. Suppose if there is addition of another elements, then it will become another two determinants, means total you will get it four determinants. First let me explain this property, then I will explain you what I am saying right now. Now listen, if any row or any column is a sum of two or more elements, then the determinant can be expressed as sum of two or more determinants. Let me prove this. I am taking LHS. I am opening expand using R1. Okay. So if I expand this, delta equal to, now A1 plus alpha into delete corresponding row column B2C3 minus B3C2, and then minus B1 plus beta into, keep it in bracket, A2C3 minus A3C2 plus C1 plus gamma into, if I delete corresponding row column, we will get A2B3 minus A3B2. Okay, fine. Now what I'm doing here, now I'm splitting into delta equal to, now listen better, what is meaning of this? A1 into this plus alpha into this. Now what I'm writing, A1 into, first I'm collecting A1, B1, C1. Now A1 into, I will get B2C3 minus B3C2, and then minus B1 into, I will get A2C3 minus A3C2, and then plus C1 into A2B3 minus A3B2, and then plus alpha into another determinant. I am taking plus alpha into, again alpha into this, that is alpha into B2C3 minus B3C2, and then minus beta into, if I take this A2C3 minus A3C2, and then plus gamma into A2B3 minus A3B2. Now listen beta, if I associate the first row if I associate in determinant form, what I will get it, A1, B1, C1, then A2, B2, C2, then A3, B3, C3. And then plus, what about second row? Second row, if I write in determinant form, that is alpha, beta, gamma, then A2, B2, C2, and then A3, B3, C3. So I have taken LHS, I am getting RHS. So what property is saying, if any row or any column is a sum of two or more elements, then the determinant can be expressed as sum of two or more determinants. So what I did here, with the help of R1, I have opened it, then I simplified, then I have written in the form of determinant, I am getting RHS. Are you clear, beta? Are you clear? Yes? Say yes, no.
Yes, ma'am.
Yes. Write down. I will explain more. This property, let me explain, then I will write last property. First you write down. Fast, better, fast, time is running. Write fast. Today no homework. Once again you revise this topic, determinants and properties read out thoroughly, then we will take class tomorrow. Okay, fine. Now, have you written, everybody? Bit fast, hurry up. Done. Yes, beta.
Yes, ma'am.
Everybody?
Yes, ma'am.
Yes. Beta, now listen, what I told you here, suppose I'm raising this, in this property, what I told you here. Suppose if there is no beta here, okay? So we can split this determinant into two form, but instead of beta, there is no addition of another element. So here you have to write down 0. Even if there is no gamma, even we can split into two. If any row or any column is the sum of two or more elements, then the determinant can be written as. So here there is no gamma, you can write it here 0. Suppose in case here alpha plus beta, another element, then we can write this as a beta, b1, 0, 0, then a2, b2, c2, and then a3, b3, c3. That means here 3 elements are addition, so we are getting 1, 2, 3, 3 determinants. If there is element, write down element, otherwise you can write it as 0. In case, are you clear with what I am saying? Are you clear? Say yes, no.
Yes, ma'am.
Yes. That means any row, suppose another row is addition of 2 elements, another 2 determinants means you will, any row or any column might deter. कोई एक रो एक कॉलम का बताया, every row every column नहीं बताया. That's keep in mind. Now last property number 7, better write it, another most important property. If any row, if any row, साथ लिखो, if any row or any column ये unique multiple of, unique मतलब equal, okay, unique multiple of another row or column are added, then the value of determinant remains same. Then the value of this property frequently we will use. Then the value of determinant remains same. Once again, if any row or any column, a unique multiple of another row or another column are added, then the value of determinant remains same. I am taking example, let delta equal to, I am taking this is a1, b1, c1, and then a2, b2, c2, and then a3, b3, c3. If I open this, so leave it this one. This is equation number 1. Now what they are saying, any row or any column, beta I am taking R1. R1 can be written as any row or any column, a unique multiple of another row, either R2 take it or R3. You cannot take R1, R1 can be written as K into some C1. If you take row wise, then you have to do row wise operation. If you take column wise, then you have to do column wise. So R1 can be written as R1 plus K into R2. Now once again, any row or any column, the unique multiple of another row or another column are added, then the value of determinant remains, you will get it delta. That is a property. Now I am doing this operation better. So R1 can be written as delta 1 equal to R1 plus KR2, R1 plus KR2. That is A1 plus KA2, B1 plus KB2, then C1 plus KC2, then remaining same A2, B2, C2, and then A3, B3, C3. Okay, fine. Now, right now we have seen one property, any row or any column is a sum of two or more elements. Then the determinant can be expressed sum of two more determinants. As per that, we can write this thing divided into two determinants, that is A2, B2, C2, and then A3, B3, C3, and then plus again K into A2, K into B2, K into C2, and then again A2, B2, C2, and then A3, B3, C3. Now that is equal to, this becomes a delta, delta 1 equal to, we are getting delta plus 0 since R1 and R2 are proportional. Since reason you have to write R1 and R2 are proportional. So that is equal to delta. So what property is saying? If any row or any column is a sum of a unique multiple of another row or another column are added, then the value of determinant remains the same. We are getting same determinant and we have used some properties. So there are two properties we have used. One is we have split it into two determinants, and another one property we have used here, proportional. So once again, what property is saying? Any row or any column, a unique multiple of another row or another column are added, then the value of determinant remains same. Are you clear, beta? Are you clear? Say yes, no, yes. Yes, you have to revise all 7 properties and first exercise so that we can do the properties of this exercise very smoothly. If you know properties, then only we can able to solve all questions. Clear to you? Now you want to discuss anything? You want to ask, doubt anything? First write down fast.
What's written after delta plus, therefore R1 and R2
Are proportional. Are proportional.
okay.
Are proportional. Okay. Then any other doubts, beta? Have you written, everybody?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. Shall I end the class? Shall I end it, beta? Okay, thank you.
Thank you, ma'am.
Thank you. Thank you, everyone.
Thank you, ma'am.
Okay, beta. Thank you, everyone.